Guys.
Hi, Mr. Sullivan.
Is Caitlin in here? How you doing? You can start with a new class. I'm trying to recruit you for right now. If you're passionate about stats, then you can tell me get out of here. So it's called data science. Yeah. Am I wrong in saying at one point were you thinking about computer science? Are you not anymore? What's that? Okay. So this is like looking at big sets of data, using some stats and probability, and some computer programming. But if you, what is your schedule look like next year? I'm putting you on the spot. Right. Your schedule's so full. Okay. So it might not be for you if you don't have any free periods in your day. I guess the only thing would be is if you didn't want to take stats, this would be an option. Are you passionate about AP stats?
Not really. You just told me that I didn't need to take help for nurses.
Right. This would probably be slightly less intense than AP Calc or AP stats. I don't know if that interests you at all. I can get you more information. I'm just gonna mark down. Do you want to stop? You know where my room's at? It's like 3 doors down or something. 338. You should just stop by it, and I can tell you a little bit more about it. But yeah, just get out here. I won't bug you. But I can look at your schedule online and tell you if it makes sense. And so, what did you say you want to go to school for?
Physician's assistant.
Physician's assistant. Okay. All right. Cool. Stop by. See you guys. Hey.
what? I got something for you to fill out here. Woo, woo, woo. Just need a pencil. Don't need a calculator piece. Nothing like that. Just need a pencil. Dun, 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 doo, 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 doo. For those of you who are at home, I'm going to put this up on the board, and you can just do it on your own piece of paper. This is not for this is not a quiz, so don't freak out. Okay, this is a knowledge check. That's all it is. So again, for you people at home, for you homebodies, you're going to be just doing this on your own piece of paper. And I'll put it up on the board so they see what it is. The Smart Notebook. Print. Where's it going to show up at? Here or there? How's your day going today? Anybody have a great day so far? Like it's been like super, super duper great, fantastic, wonderful? Okay, I don't even want to ask the flip side of that. Has anybody had a really bad, horrendous, horrific, terrible, no bad, cruddy old crappy day so far? That's good. That's good news. Where did that sheet go? It's like it didn't print like I wanted it to. Why print? You're supposed to print to a Smart Notebook file. Ah, there we go. First you don't succeed, try it again. That adage is a good idea sometimes. You guys are going to see what's up in a second. So you're not going. This is what you're going to get in a second as well. If it loads. Yesterday in my Smart Notebook, during my second block class, I was in the middle of notes and it froze and shut down and I lost everything with them. So it was kind of like, oh, that's not cool. You know, I hate when that kind of stuff happens. Yeah, that's not right. I don't think it's working still. Smart Notebook's not. But I'll get you guys started. Onliners, just hold on. Oops. Yep. Here, Ryan. All right. Yeah, it's not even doing it. So I will. There it is, my onliners. Okay, onliners, here you are. Please try this. Oh, when are you doing this? Okay. Not a test, a quiz. Yeah. Let me think about how we're going to handle it. I got to see when I have to have grades too, right? Okay.
Okay. I'm going to be like doing online now.
Okay.
So,
all right.
I might be able to do it online.
Okay. That's an idea. And we're only going to, I want you to just do this for like maybe 3-4 minutes, what you know. Like I said, this is where are you at right now? This is for me to know, for you to know. Scroll this up for my onliners. We've got another minute. So for your so I'm going to fill in these. What we could do, okay? I might ask you to tell me what they are for each of these. So in each one of these, I'm supposed to write down as many equivalent identities as I can. Okay. So all of them that you can remember for each of these. Okay. So identities are not using x's and y's. Identities are rewriting as other trig functions. That's an identity. So first one here, sine theta. 1 over cosecant of theta. Is there anything else that we have for that one? There's no other identity we have, is there really? Yeah. But that's defined on the unit circle. That's just defined on a circle. So so we want to define it in terms of what's it equal to as another trig function. That's it. Same with cosine. Cosine is what? 1 over. Okay, tangent. This one's going to have 2. It's going to have 1 over cotangent theta. And it's also going to have sine theta over cosine theta. Okay? Cosecant theta. That's 1 over sine theta. Okay, so we'll go ahead and do this. So 1 over sine theta. Secant theta is 1 over cosine theta. Cotangent is going to have 2. It's going to be 1 over tangent theta as well as cosine theta over sine theta. So these first ones on each of these are the reciprocal identities. These two are the quotient identities, I call them. Okay, these three, we're using even odd identities. Anytime you start seeing negatives involved, you're thinking even odd identities. Okay, so here we go. Cosine of negative theta. Cosine positive theta. All right, tangent of negative theta. Negative tangent of theta. Boom. Negative sine theta. Sine of negative theta. Fantastic. Now I only chose those. Okay, why did I choose just cosine, tangent, and sine? Because if you know those, you automatically know the other three, right? Because the reciprocals are the exact same as these as far as being even or odds. And then down here, these you had to just know what they are. Okay, so order doesn't matter. The first one you most likely wrote down, if you wrote one down, was, maybe you wrote down cosine squared theta. Sine squared theta equals 1. Again, if you wrote sine squared plus cosine squared, that's the same thing. Okay, this, if you put it out here, is technically wrong because that's saying you're going to square the value of theta. Because you're really squaring the cosine is what you're really squaring here. Okay? So yeah, that's a simple thing to take care of. All right, now, the other two we just learned yesterday. Right? So the first one, they both start off as 1 plus. So here, 1 plus tangent squared theta equals and just so you get there, the other one's going to be 1 plus cotangent squared theta. So now it's all about, do you know what goes on the other side? Ryan, the first one, are you giving me the first one here? This one? Okay. Secant squared theta. The other one is cosecant squared theta. The easiest way to remember these is that the cotangent and the cosecant are in the same equation. Okay? Boom. So those are the three Pythagorean identities. Okay, so again, those are things that you're going to need to be studying and remembering. We want you to be able to start substituting equivalent things for trig statements you might see. So if I wrote down, like if I wrote this down, let's say I wrote this. Guess what a person could write down for that? What do you think 1 minus cosine squared theta is? It's what? Somebody just said it. It's just sine squared theta. All it is this equation what? I just did what? Subtracted cosine squared theta from both sides. If you know this, you actually know other things as well. Okay? You can identify other things in the future. So, and there are reasons I say these things to you. Because whether you don't realize this, but like this right here, down the road, this you might see like this. That's that in factored form. Because that's the difference of two squares. So this gives you this, which means you're only dealing with sine squared theta. So we really need to know these so that we can work with them better. Okay? It's going to make our life easier down the road. All right. That's enough of that. Flip it over. On the back, you're going to do something for me right now, too. So this is all, so far, this has been review. All this is, why is this showing up on every page? I don't need that many pages of this. What in the world's going on? Well, let's just put a new page in here. All right. I'm going to give you an angle. I'm going to give you theta. And theta is 5 pi over 8. Okay? Theta is 5 pi over 8. Now, my first question is that a familiar angle? No, because familiar angles always end in, they have a denominator of what? 6s, 3s, 4s, or 2s, right? Or even like a 1 if it's pi or 2 pi, right? That would be over 1. But so if it's over 8, that's not a familiar angle, okay? So here's what I want you to do. There's a few things I want you to do. I wrote it down for myself. First thing I want you to do is sketch where the terminal side is approximately. I mean, am I expecting it to be exact? No. But you should be able to give me an approximation of where it should be at roughly. Okay? Sketch it. The next thing I want you to do, the second thing is, this is review, give a positive coterminal angle to theta. Then I'm going to want you to give a negative coterminal angle to theta. And the final thing I'm going to ask you to do, this we have not done much of this, so we'll see if you remember how, is to convert theta to degrees. We'll see if you remember how to do that or not. Okay? So sketch it in standard position, right? Give two coterminal angles, one positive, one negative, and then make it in degrees instead. Just get those. Think about another minute and finish up. Okay, here we go. So let's go ahead and sketch this. So can you at least tell me which quadrant the terminal side is going to be in? It's going to be in quadrant 2. Okay, now, if you're, I want everyone to just think about it. I told this is not a familiar angle, but think of this. Everyone should know what this angle right here is that's smack dab in the middle here. What is that angle in radians? Pi over what? 4, right? This is pi over 4. So guess what? If I only went halfway up, guess where I'd be at? Pi over 8. Now, so it's not a familiar angle, but I could actually get a mental idea of where it is. Okay? So let's think about this. This would be 1 pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. So it's about right there. So that angle is about right here. Here is theta. Again, I just thought through on the whole idea, well, I know what pi over 4 is. Pi over 8 would be half of that, so I know that's here. So I just kind of went through it on a logical step of counting by pi over 8. 1, 2, 3, 4, 5. Okay? Give a positive coterminal angle to theta. All I have to do is add what? For number 2 here, it's just what? 5 pi over 8 plus what? 2 pi. All right, now look. Make this easy on yourself. Okay? Think of this as a mixed number and just turn it into an improper fraction. How do you take 2 5/8 and turn that into an improper fraction? You go 8 times 2 plus 5. Right? So it's 16 plus 5, so it's 21 over 8. And I can't forget the what? Pi. So it's 21 pi over 8. If you put 21/8 pi, that's the same thing. So if it's a mix, if this is nothing more than a mixed number. When you're adding a coterminal, those are the easier ones because you can just treat it like a mixed number and turn it into an improper fraction and you're done. Part 3, though, over here, now I have to do, I don't want to add 2 pi, I want to subtract 2 pi. So I'm literally going to do 5 pi over 8 minus 2 pi. Now I can't do that trick right here now. So I have to get this with the denominator of what? 8, which means I'm doing 5 pi over 8 minus 16 pi over 8. So now, literally, what am I going to get? Something over 8. What? Negative 11 pi. Okay? So there's the coterminal angle to it. And the last part here was to convert this to degrees. So how do I go from radians to degrees? What do I do? Multiply by 180 over pi, because 180 degrees is the same as what? Pi radians. So literally I would take 5 pi over 8 times 180 over pi. So what's going to happen? The pi symbols are going to cancel out. I'm going to multiply this out. So here, if you did this, you'd get 5 times 180, which is 900. So it's 900 divided by 8. And that would give you, I think it's 112.5. Okay? So I know we haven't, like yesterday, I didn't do anything like this, but these are things that we should have an idea where that angle is. Since we know our familiar angles, we should be able to kind of give a sketch of it. We should be able to do coterminal angles because we have said that enough in here. And then I know we hadn't done a lot of converting, but still, that's something you should be able to do. Okay? All right. So, are you ready? Keep going? Yeah? Okay, so this next part, you don't have to write all this down. We'll just talk through this next part together. I'm going to do that one. I think this is, there we go, good. All right, so here we go. So everybody in here knows what this means. Boom, okay? Everybody in here knows what that means. And hopefully everybody in here everyone in here could tell me what the cosine of theta is, the sine of theta is based upon the unit circle. Like everyone in here could tell me that the sine of theta is equal to, what is the sine? This is not a familiar angle. I didn't give you a degree. I don't know where that is. It might be right in the middle, but I don't think it is. This is not a familiar angle necessarily. In general, on the unit circle, the sine of theta is equal to y. Perfect. And the cosine of theta is x, and the tangent of theta is y over x. Okay, that's what we kind of started off a while ago. Okay, and then of course, if we know those, we know the other ones, right? So we know that the cosecant of theta is 1 over y. So these are not identities. This is how it's defined. These are not identities. And then the secant of theta is 1 over x, and the cotangent of theta is x over y. Boom. So that is for the unit circle. Again, we don't know what that is. Okay? All right, so what happens when now all of a sudden we want to define the 6 trig functions on a circle with the radius of r? What happens? How does this change? Who remembers? We did this a while ago. Yeah. What's that? That's how you get the radians, yeah. That's how you get theta in radians. That's true.
You take the values from the unit circle. So like if you wanted sine equals y, but you'd also take it times the radius.
Okay, so I want everyone to look over here. What is y actually over? We don't write it though. It's understood to be over 1. What's x over? 1. That 1 is the radius of 1. Because remember when I had one up here in quadrant 1 like this, remember how we did this? We went like this, here's x, here's y, that was 1, and we did the trig ratio setting it up using that. So the reason it's just y and x is because it's over a radius of 1, and we just don't write it. So as soon as it has a radius of r, all I have to do now is change all of these 1s to what? r's. That's it. So when you have a radius that's not 1, okay, the sine of theta is y over r. The cosine of theta is x over r. The tangent of theta, though, guess what? It's still just y over x. It doesn't matter if that's a unit circle or a non-unit circle. Okay? So you have to know if it's not a unit circle, if it has a radius other than 1, this is how sine, cosine, and tangent are defined. And if you think about it right here, if I were to go ahead and draw a right triangle right here, here's x, here's y, here's r, there's theta. The sine is y over r. The cosine's x over r. That's why it's true. And then we can go ahead and define the other 3 as well. So that would mean that the cosecant of theta is r over y. The secant of theta is r over x. And the cotangent of theta is x over y. So we have the 6 trig functions defined on the unit circle. We also have them defined on a non-unit circle with the radius is r. And they're really and truly saying the exact same thing. Here we just don't write the radius of 1 down. That's the difference. Okay? So are we okay with understanding those? Does anybody have any questions on either one of those? No, we're okay with that? Okay. So let's go ahead and try a problem here. It's kind of like what we did yesterday. Okay? And I'm going to show you where we're heading. Right? So everybody in here, hopefully, if I gave you this picture right here, and I told you that I want to find this angle x, and let's say I told you that this was 5 and this was 12, I'm hoping everybody in here could find x. Because we would use what trig, the first thing is saying what trig ratio we would use. What would we use? What would be our trig ratio here? Sine, right? And we would say the sine of x equals 5 over 12. This is from geometry land. So x would be equal to what? How do I write it? 2 choices. Sine -1 of the 5/12. Or you can write x equals the, what was another way of writing sine and -1? Arc sine. Okay, it's just, they mean the exact same thing. All right, great. So everybody in here knows that. So guess what? Now our goal is, hey, what if I gave you an angle on a circle, and I wanted you to find maybe the ratios, but I also want you to actually find the value of theta, the rotation we have gone through. That makes sense. We should be able to do that now too. So that's what we're going to try. So we're going to start off with a nice one here. Okay, so I'm going to go ahead, go like this. I'm going to draw my circle. Here it is. And I'm going to go ahead and draw this angle right here. And I'm going to tell you those coordinates are at, oh, how about 1, 8. Okay, now, my first question to you is this going to be a unit circle? No, there's no way it is. How do I know there's no possible way that this is a unit circle?
Because the y value is 8.
Yeah, if it was a unit circle, the y value would never be bigger than 1. I know this is not possibly a unit circle. As a matter of fact, it has to have a radius that's bigger than 8. So how would I find? I have to find the radius to start on this problem. I have to find the radius. Okay, now let's think about this, guys. That's 1, that's 8, I need r. Of course, I'm just going to do what? Pythagorean theorem. So in general, if you're given a circle and it's centered at the origin, x squared plus y squared equals r squared. That's true for, that's a circle, okay? That's true for a circle that is centered at the origin. So I could just go, oh, 1 squared equals r squared. So that's 1 plus 64. So r squared equals 65. So what, do I have to worry about positive and negative roots on this? No, we don't have a negative radius in this. So r is radical 65. Boom, got it. Okay, so now I know that r is this. I should be able to write down any of the 6 trig functions if I want them. I should be able to write down any of the 6 trig functions, okay? Here's theta. So somebody tell me what the sine of theta would be equal to. So what's y? 8. Yeah, so the sine of theta would be 8 over radical 65. What would the cosine of theta be? 1 over radical 65. What would the tangent of theta be? What's that? 8 over 1. Okay, great. Now here we go. I need everybody to make sure that their calculator or whatever they're going to use is in radians, because I want this in radians. All right? I want the following. Are you ready? Row 1. Domino's row. You're going to use sine to find theta. Okay? Row 2. You're going to use the cosine to find it. And then these 2 rows, I want you to use the tangent to find it. Is that okay? And what better be true? When I get done asking you guys what you got, what better be true? It better be the same. Round to the nearest 100th, 2 decimal places. Let's just round to the nearest 100th, okay? We got another 30 seconds here. I'm going to ask what you guys have. You guys in your rows can like check, see if you have the same thing. Okay? So check, see if you guys have the same things in your rows. So that when I ask somebody in the row, they can give me an answer that you all agree on.
Oh, radius. It's just
Okay. Who's going to give me the answer on row 1 over here? Who's going to tell me? You guys, did you guys have an answer you agreed on? Ford, what'd you get? 1.45. Okay, so row 1 says it's 1.45. Okay, row number 2, who's telling me? Andrew, you got it? You got the same thing. Okay, and over here doesn't matter which row. True. So you guys all got the same thing, 1.45? Perfect, I love it. That's great. Love it. Fantastic. Now, I have a question for you. If I was going to give you another problem like this, okay, so if I was just going to sketch a new problem like this, let's just say I did it, I'll just do one right here. And if I went ahead and said, oh, my angle theta is right here, here's theta, and this is at, oh, I don't know, how about 6, 2. I want somebody to tell me if all I wanted you to do was give me theta. All I want you to do is give me theta. Do you have to find R? If all I want is theta, do you have to find R? And the answer is, why not? Because you can automatically use the tangent if you're given y and x, correct? Okay, so that's nice. So if I give you one, you don't have to find the radius if I want an angle of rotation given the coordinates of the terminal side. You do not have to do it. You could just go ahead and use tangent every single time. So here I would say, oh, theta would be what? The inverse tangent of what? 2/6, right? Boom. And then I could give an answer and I'd be done. So we're all in agreement with that, right? So you would only need the radius if I wanted the sine, or if I wanted the cosine, or the cosecant, or the secant, correct? Okay. Fantastic. All right. Owen, are you ready? Sure. All right. Owen says he's ready. So does anybody have any questions on this? What we just did here. So I'm going to give you one to do on your own now. Okay, here we go. Shoo! Woo! Woo! I'm in a good mood today, guys. Beautiful out. It's going to be 77 degrees. After school, go outside by yourself with the mask off and just go and breathe in some clean air. All right, here we go. I'm going to draw my angle in standard position. Shut up. Whoop. And I'm going to tell you that this is at about 6, 7. I'm sorry, -6, -7. My bad. Please find theta. Oh, when you come back, we'll talk about this, okay? Why do you have so much energy? Not like outrageous.
I haven't done
Beautiful.
All righty. So you guys were sitting here. You must have been working on this already. So somebody tell me how I'm going to find theta. Theta equals what? Just like I did on the previous page. What do you want me to do? Yeah. Arc tangent of -7 over -6. Great. Right? Y over x. Okay, fantastic. So, if you do this, and let's just round it to the nearest hundredth again. That's completely fine with me. We'll just round to the nearest hundredth. Okay? What do you get for theta?
0.86.
0.86. All right, now, does this angle, if I know from here to here is pi, which is about 3.14, right? Is there any way that theta, which is larger than that, could be 0.86? Don't worry. You didn't do anything wrong. What you've done is exactly what I knew you would do. And I planned for you to do. Because that's how we're going to learn this. I mean, is there any possible way that theta is 0.86? And the answer is no, it is not. Okay, so here we go. Everyone, stick with me. I'm going to draw a right triangle. Here it is. Right? This is what? -7, and this is -6. If I do arctangent of this, if this is opposite, that means I just found this angle right here. This is the angle I found, which is what you had to do. You had no choice. This is 0.86. So how in the world do I actually get what theta is? Theta is what? What's that? Yeah, it's pi plus 0.86. Does that make sense? What we just did? What happened there? Okay, now we have this right here is very important. This angle that you found right here, this one, is called a reference angle. Okay? It's called a reference angle. A reference angle is an acute angle. I'm going to write this down here. Reference angle is acute angle formed by terminal side and the x-axis. Here's the x-axis, here's the terminal side. That's what this is. This is called the reference angle. It's called the reference angle. Okay? We need to make sure that we can find theta if we know the reference angle. Okay? So in other words, our next step, before we do any more problems like this, is we're going to go ahead and just find theta given a reference angle. All right? So again, the reference angle is the acute angle formed by the terminal side and the x-axis, not the y-axis, the x-axis. So you have, this is a definition. If you don't remember what this means, it's going to hurt you later on, trust me. It's going to hurt you when we start solving trigonometric equations in here. You must understand what reference angles are if you're trying to solve for theta, an angle of rotation. All right. So let's try this. All we're going to do next is reference angles. All we're going to do right now is find reference angles. That's it. Here we go. I'm going to draw multiple pictures on this page. So let's go ahead and go whoop, whoop, whoop. Here's theta. All right? That's the angle I want. Now, can somebody tell me where the reference angle is if I'm in quadrant 1? If theta is in quadrant 1, what can you tell me about the reference angle? Somebody give me a good comment here.
It's the same as the angle you're trying to find.
It's the same as the angle I'm trying to find. If I'm in quadrant 1 and I'm finding theta, then the reference angle is the exact same thing in quadrant 1. So here, if theta is in quadrant 1, if I'm in quadrant 1, theta is equal to the reference angle. Okay? That makes sense? Okay, let's go to quadrant number 2. So now we're down here. Let's do quadrant number 2. All righty. If I'm in quadrant 2, here it is. This is theta. Okay? The reference angle is an acute angle between the terminal side and the x-axis. That means this angle right here is the reference angle. Does that make sense? It's between the terminal side and the x-axis. This is the reference angle. So how are we going to find theta if we're in quadrant 2? Pi minus the reference angle. Thank you very much. Pi, so theta here is going to be pi minus the reference angle. Okay? All right, let's head to quadrant 3. Quadrant 3. So now I'm down here. Here's theta. The reference angle is between the terminal side and the x-axis, and it's got to be an acute angle. So it's this. This is the reference angle. So how am I going to find theta on this one? Pi plus the reference angle. Oh, I don't know the way that looks. That's okay, I guess. Pi plus the reference angle. Boom. Done. Got it. Do all three of those make sense? All right. Last one is, of course, quadrant number 4. So if I'm in quadrant 4, here we are. This is theta. This is the reference angle right here. Here's the reference angle. What's theta going to be equal to? Okay, if I use the reference angle, that would be a negative angle though. I gotta be careful. If I'm looking for positive angles, what did you say? Yeah, it's going to be 2 pi minus the reference angle on this one. Theta equals 2 pi minus reference. Oh, I knew that was going to happen. Minus the reference angle. Okay. So we need to know that. That's going to be important later on in here. It's going to be important later on. Okay? All right. So the nice place, where would you like your angle always be? Quadrant 1. That's the nice ones. They're not always going to be in quadrant 1. We know that. Okay? We know that's not going to happen. Okay. So let's go ahead and try a few where you're going to find the angle for me. All right? Here we go. We're going to this is a learning day on this right now. So I'm going to go ahead. We're not going to worry about quadrant 1 because you guys can all do quadrant 1. I know that. So let's go ahead and go into quadrant 2. Okay? So we're going to go to quadrant 2. I'm right here. Here's theta. I'm going to tell you right now that theta is at 3, 5. Would you please find theta for me? I'm going to put down, while you're doing that, I'm going to put 2 more problems here as well. So we're going to find theta on all three of those using what we just learned, reference angles, and where we're at, what quadrant we're in.
Wouldn't the 3 have to be negative?
Oh yeah, sorry, that's a -3. My bad. Sorry about that. It's here. Beautiful. Okay, so if you're setting them up like this, fantastic, okay? So if I do this, what do I get for theta? And again, we're just going to round to the nearest 100. Not for theta, I'm sorry. If I do this, I'm going to get the, not the theta, actually I'm going to get what? The reference angle here. So I'm going to put that down. Reference angle equals what? What do I get for the reference angle here? Anybody get an answer?
Wouldn't you do it by 5/3 because you can't have negative lengths because you're looking at it like a right?
We're going to do it this way, and we're going to talk about that in a second. You're fine. We're going to talk about that. Yeah. Krista? -1.03. You got? Did I have confirmation on that? Okay, great. Now, Miss Wetzel has asked, wouldn't it just be positive values? Okay. If I think of it as a right triangle, because right triangles never have negative lengths, I could think of it like this: the reference angle, and would be equal, not negative, but it would be inverse tangent of just 5/3. Okay, and if I did this, I'm going to get 1.03. If this was right, then this would be 1.03. Is that what you have, Wetzel?
Yes.
Okay. Now, let's think about what that's saying to us. This one is saying I have to go from pi, but I have to go backwards 1.03 radians. So this angle here, okay, if I go from here to here, it's -1.03. That's how I would get theta. If I think of this as 1.03, that would be this way. So remember what we said if it was in quadrant 2, what do? We said we subtract it from theta, right? Or from pi. This is where I have to be careful about what did I do? How did I approach this, okay? If I did this, I don't want to take pi minus -1.03 because that would actually add to pi, wouldn't it? So if I do it this way, it would literally be what? Pi minus 1.03. If I do it this way, it's pi minus 1.03. Either way will work. What you're going to want to do is decide which way are you going to approach it. If you just want to keep these as positive when you're doing the tangent, okay, and always do the subtraction, that's fine. If you want to just use the ordered pairs, and based upon where you are, you should know what you're going to do. It'll work the same way. All right? Krista.
What if you write next to underneath the third circle that we're working on?
Here?
And the black.
This?
Yeah, what's next to
This says reference angle is the inverse tangent of positive 5/3. So this time I didn't use any of the signs. I just used the y and x, the absolute value of them. Okay? Because it gives me the same angle when we talk about absolute value. So it's all about where am I and what do I want to do. Some people will literally go ahead and they'll use these instead of having to think about always changing the signs. It's up to you how you want to approach it. It is not said that you must do it one way or the other. You have the freedom of which way you want to do it. Okay? It's the freedom of what you want to do. All right? So this one over here, is it even going to matter on this one? What we just talked about? Here it's not going to matter. Why? Because it's going to be a positive either way I do it. So this one, it's going to be pi plus the reference angle for sure. So can somebody just give me what is the reference angle right here equal? What is that reference angle equal? Pretty small. 0.32. Okay? So, and by the way, up here, let's just write this down. Theta here was equal to, theta here was pi minus 1.03, whatever that gives me. On this one, theta is equal to pi plus 0.32. Okay? Last one down here. Can somebody give me this reference angle? I don't care if it's positive or negative, it doesn't matter to me. 1.17? Okay? So if I want to find theta down here, theta is going to be equal to 2 pi minus 1.17. Yes? It's dependent. You know, it's according to what I want. If I said round your answer, then I want you to do it. If I said leave it exact, then you might just like that for me. That'd be fine. Okay? If you did that, I would actually know you understood how to find the angle though. That's fine. It's all dependent upon what does the question want you to put your final answer as. Okay? Anybody have questions on this page? Nobody has any questions on this page? All right. Are you ready to try something else? Here we go. By the way, yesterday, review again. We're kind of flip-flopping back and forth. This is kind of important. On any circle, which trig functions, there's 6 of them, which ones are positive in quadrant 1? All of them. Which of the original 3 is positive in quadrant 2? Sine. Now, if sine is positive here, what else is positive there? Cosecant. So sine and cosecant, because they're reciprocals, are the positive ones there. Here, they're all positive, okay? Quadrant 3, what's positive? Tangent and cotangent. Okay? And then in quadrant 4, cosine and secant are positive. Okay? Cosine and secant are positive. This was from yesterday. We talked about this, right? Okay, fantastic. So, here we go. We're going to play a little game. What quadrant is theta in? Don't say anything out loud. I want you to think. Okay? First one. Okay, so read that to yourself. I want to know what quadrant is theta in. What quadrant is theta in? Who wants to tell me where theta is? Theta is in, and when I say that, where's the terminal side at? Brady. Quadrant 3. That is the only quadrant where sine and cosine are both negative at the exact same time. Okay? Here we go. Next one. Let's do this. I wrote down some problems for us to try. Here we go. Okay? And I'm going to show you how you can get to doing these with just a little bit of marking up of things. We're going to do this one this way, okay? All right, so secant is positive. What if I only gave you this? Which quadrants would you be looking at? If I simply told you that secant is greater than 0, which means it is positive.
1 and 4.
1 and 4. So for this guy right here, I'm in either 1 or 4. I'm now going to look at this guy over here. Where's the cotangent negative at? Which 2 though? Give me both. 2 and 4. Where do you have both symbols at? Quadrant. So you're in quadrant 4, in other words. So quadrant 4, I would be at for this one. Theta is in quadrant 4. Okay. Let's try another one here. Let's go. Where's the cotangent positive and the sine negative? What quadrant? 3. This is in 3. Okay. One more. Let me get purple up. Here we go. Yep, there we go. What quadrant's the purple one in? What'd you say, Stacy? 2. It's in quadrant 2. Tangent's negative in these 2. The secant's positive there, so I have to go over here in quadrant number 2. All right? Deciding where I'm at. All right? You okay with this? This is just using our knowledge of where are they positive or where are they negative based upon the coordinates x and y, right? That's it. That's all we're doing. So let's go to that final step. Here we go. Okay, so I'm going to give you the following. I'm going to give you that the tangent of theta is equal to negative 2/3. And I'm also going to tell you that the cosine of theta is less than 0. Here's what I want to do. I would like the sine of theta, the cosine of theta. I already have the tangent of theta. I would like the cosecant of theta, the secant of theta, the cotangent of theta, and I also want to know what in the world does theta equal. I want all of this now. Okay, so we're going to do this together, this one, and then I'm going to give you one to try. Don't start throwing stuff now. It's okay. Calm down. So the first thing I have to do up here is decide what quadrant am I in. I need to know what quadrant am I going to be in. So here we go. So I just draw this. So the tangent is negative Where is the tangent negative at? 2 and 4. So this, I have to be in either quadrant 2 or 4. Here, the cosine is also what? Negative. What quadrants is the cosine negative in? 2 and 3. That means I must be in quadrant number 2. So I know I'm in quadrant 2. All right, great. If I'm in quadrant 2, tell me what you know about the ordered pairs.
X is negative, Y is positive.
It's a negative x and a positive y. Why does that matter? Look where I jammed that negative. Right smack dab in the middle of that fraction bar. I didn't tell you if it was in the 2 or the 3, did I? You have to know where to put it then. Which of those numbers is the negative number? Tangent is what? Y over x. So I know the negative number is the what? The 3. So this right here, I need, on my own, I have to get through this and say, well, I really know that this is 2 over negative 3. All right, great. Here we go. What do I need to do next? Let's get these done first on the left. What do I have to find? What I did something like this earlier, guys. What did I have to find? I didn't give you the tangent. I just gave you the, didn't I just give you the ordered pair if I gave you the tangent? What did you have to find if I gave you the ordered pair? Yeah, if I want the sine and the cosine, what did we have to know? Sine is y over what? R. Do I know R? No. Can I find it? Yes, because R is what? X squared plus y squared equals R squared. I need to find out what R is. Okay, great. Let's do that. Here we go. Sidebar. So it's going to be, let's just do this in our head. Squared plus squared. What do we got? 9 and 4 is? So R is the square root of 13. Again, what did we do here? X squared plus y squared equals R squared. That's how I got this. And R is always positive. Okay, I should now be able to write these. I should now be able to write these because I know R is this, and I know my ordered pair is what again? Negative 3, 2. Writing these should not be an issue then, if I know how they're defined on the circle. So the sine of theta would be equal to what? 2 over radical 13. Okay, great. The cosine of theta would be negative 3 over radical 13. Boom. The cosecant of theta would be radical 13 over 2. Fantastic. The secant, of course, would be radical 13 over negative 3. And the cotangent I could have done a long time ago is negative 3/2. Boom. Great. All right. So questions before we go any further? No? All right. Now what do I want to do? Now I want to find theta. Okay. When I'm at this stage and I'm finding theta, I can use any of them that I want. Okay? So let's do that. Which one do you want to use? Tangent. All right. So we're going to do the tangent. So theta, we're going to find the reference angle. I'm just going to put reference of theta equals the inverse tangent. And again, at this point in time, you can make them both positive. You can keep the ordered pair the way you want. It is up to you. It does not matter. So I'm going to go ahead and do what? What I was given is negative 2/3 right here. So that's going to give me the angle going backwards towards the terminal side. What do I get for the reference angle to the nearest hundredth? Geiger. 0.59. So if you did this, you probably got a negative 0.59, which is completely fine. It doesn't matter. You can think of it either way you want. What do I know theta is though? Theta is going to be pi minus 0.59. And I'm just going to leave it like that. That is completely fine. How are we doing with this, guys? Are you feeling pretty good about it? Yes? Are we feeling better about it? And look, all of this stuff I'm doing with you is because what you're doing, when you do this right here, you're solving a trigonometric equation. This is a very, 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 very basic trigonometric equation. It's an equation that has an equal sign, and you're solving for an unknown value of theta. That's what we're doing here. Later on, you will be solving ones that are much more difficult than this. Okay? All right. You ready? Here we go. Last one. I want you to find theta if the cosine of theta is equal to -3/7 and the sine of theta is less than 0. All I want to know is theta. I don't want to know the other trig values. I just want to know what is theta. I want you to try this. See if you can take what we're doing and kind of decide, okay, we've got a lot. I have to use some of this knowledge from today to do this problem. So everyone try this one. Yo!
Is that negative on the 3 or is it just on whole fraction?
It's on the fraction. Now, I do know that it's on the 3 because cosine is what? X over r, and radius is always what? Positive. So I know it is on the 3. It has to be. Okay? Has to be. I don't want that. I don't want, yeah, so this is what I want. Okay. Let's see what we got here. Do this, and then I'm going to give you your problems. They're going to be on the board. I'm going to write them down in a second. So, talk to me. What quadrant am I in, by the way? Where is cosine negative and the sine also negative? 3. Thank you very much. I know I'm in quadrant 3. Okay, now, I have to make a decision here. I can either go find R if I want, or may I have R. I can go ahead and use the Pythagorean theorem and find what? The missing value of y, and then I could go ahead and switch over to using tangent if I would choose to. Or I could just use the cosine one instead. Let's go ahead and think about this. We know we're in quadrant 3, guys. We know it. I'm just going to draw where it is real quick, okay? So we know we're in quadrant 3. Let's just say it's right here. Let's say that's theta. If I draw my right triangle, guys, like this, okay? Draw the right triangle. We always draw from the x-axis, right? This is, which one's 3? Is this one or this one? Which one? This one. This is negative 3 or 3. It's your choice how you want to think of it. I'm going to make it a positive 3. This is a positive 7. That means I'm going to find this reference angle here, and when I get it, what am I going to have to do? Add it to pi. We need to start thinking through, because I don't want to waste time finding all the values to find tangent every time. You won't get things done. So here we go. I'm just going to do theta equals the inverse cosine of 3/7. I'm just going to do the positive one this time. I'm going to get this angle right here, what it is. Okay? So what do I get? Yeah. 1.13. So the reference angle is 1.13. So theta then would be pi plus 1.13. Do we agree on that? How many of you found tangent to do this? Okay. Is that wrong? No. Does it take more time necessarily? Yes. Reference angle is the key. You can use any sine, cosine, tangent. Any of those can be used to find the reference angle. It doesn't matter which one you do. All you have to always do is remember, are you going to add to pi, subtract from pi? If you're in here, it's going to subtract. If you're here, you're going to add. If you're over here, you're going to subtract from 2 pi. Where are you at? All you have to remember. All right. Tonight, I will post all of this stuff after school so it's online. All those problems. Here we go. You're going to find theta given the terminal sides coordinates. Okay, you are in theta is between 0 and 2 pi. We're not doing any negatives right now, all right? Here we go. And I'll post this online, so if you don't get it written down, you can just call it up tonight and you can look at it. It will be there on the last page of the notes. Okay? I'm going to tell you that zero. The last one is number 6 is give remaining. You guys, I would just go ahead. You don't have to stick around. Like I said, it'll be online. Give remaining 5 trig values if
You look at game. It's like there's things on the wall.
oh wait, no. Oh, what?
He makes it where you can do it. I got pretty far. I had almost halfway. I put some before. No. He dropped me. Did she give us stuff for birthday? Did she give us stupid?
All right. Put all that online for you guys to see. Had lots of problems.
No, I just gotta run this size there. It's a little-
Take another picture. I'm sorry. I didn't mean to be a jerk on you there. I want to save as. Save. Four. Hello. How are you doing today?
I am good. How are
You
you?
can put that wherever you want. Just get it out of the
Oh,
way.
I just didn't want the door to hit it.
Did you see Colette's water cooler she got for us?
For
Next to
what?
you? Look at right next to you. The water cooler to your right.
Oh my!
It's got hot water on demand and cold
What?
filtered water. Yeah.
What?
Guess who she must really like?
What?
I know. Only certain people should know.
I mean, seriously.
PDF. Page. Save. You have Will Grimes.
I know Will Grimes.
You don't have him.
Do I have him in class? Not right now, I don't.
Like I say, he's already struggling. How's Will doing? Any better? Have you talked to him again
I
today?
haven't seen him yet, knock on wood, that means he's doing okay.
Okay, that's good news. That's
My
good
shame
news.
is one who's giving me problems. That's why I was waiting for him.
He's on the How old is he?
He's a senior.
Oh no, Pumler, what do you want?
He is.
Ketchup.
She's looking
Ketchup.
for ketchup, I'm seeing if I have it.
As I say, I do not have ketchup in here. Sorry.
Oh, it's okay. I forgot some.
Oh,
products.
I know who this is.
He,
I've been seeing him walk around
like a crazy person, because he hates home instruction.
coming out of Johnny's office.
Oh, coming out of everywhere, fighting everybody.
I
He's
butter
supposed to
Maddie.
leave
Butter?
half day.
Sorry.
Which
no,
we
it's
had to
okay.
think about. He wants.
I'll just
he's
eat it
supposed
with
to
some
leave
ranch.
half day because he's on home instruction. And he told, flat out told you today, I will hide in the bathroom. I'm not leaving. I get to stay here for the whole day. You actually don't. Your half day, home instruction, unless it's coming, and keep over, I'm not going on. So now, you can't really trespass people when school goes here though. Officer thinks it's gonna be
I wondered what
shadowing
they were talking
him around lunch
Today we
to make sure he leaves.
busted their butts on reference angle. They
He said he was gonna hide in
so
the bathroom.
much. Yeah. Yeah.
Why do you want?
I just hammered them.
He still needs like 7 more credits before May. So
No,
first
right.
of all,
Why
he's
is it
probably
this
not gonna
Did you
graduate,
get
but
some of them
they're trying to
just
do
like
everything they can between home
It's just-
instruction.
it's all about who buys it.
right.
You know, it's like,
It's not,
and he.
And also, it's all about, are you going to, like, if I give you coordinates, are you gonna use the actual coordinates or are you
Yeah.
gonna composite
Remember I
everything?
was in the
Because
gym
if
that
you use the
day?
actual coordinates.
Yeah.
Correct.
then you
Well, I'm
gotta-
glad I'm not crazy.
I mean, it's just,
And I came back,